these next two questions are to do with converging areas or infinite areas and finite areas underneath those reciprocal curves. And one thing that we have to understand is, first of all, the terminology. And it says here, which of the following improper integrals diverges? Well, diverging means that it has infinite area. Okay, so we either say it's divergent or diverges, and that has infinite area. The opposite of that then would be converging or convergent, and that means it has finite area. Okay, the unbounded area is finite. So this is going to be based on these curves, and 1 over x curve happens to be our boundary curve, meaning that if we go on one side of 1 over x, for example, we increase the power in the denominator, we have something happen, and if we decrease the power in the denominator, we have something else happen, which is off the diagram to the left here. So this is a boundary function because the area from some arbitrary point A to the right is infinite, going along the x-axis, and the area that is bounded by this vertical asymptote is also infinite. Now, this is unique in that 1 over x is the only function that it is infinite on both sides. If we increase the power on x, so that means the denominator gets bigger faster, it closes down to 0 much quicker here. That makes this area finite or convergent, and it makes the area on the other side of A infinite or divergent. The opposite is true if we let the power be less than 1. So these root powers, that means that the denominator does not get small very quick, or the denominator does not get large very quickly, so the fraction tends to 0 very slowly. So this gap in here is bigger, and that means that this area ends up being infinite from some arbitrary point A, and the opposite then is true on the other side of A. Along the y-axis, this area becomes finite. Okay, so these are the principles that we're going to use. So then, looking at this question number 59, if we look at the area for a 1 over x squared function, so we can look at this diagram to the right, from 1 to infinity, well, we know that is finite, so that is not divergent, it is convergent, so we can rule that one out. From 0 to infinity, well, 0 to infinity, well, if we think of what a 1 over e to the x function looks like, okay, it looks like this. Now it is pinched off at the top because it crosses the y-axis at 1, and it tends to 0 much quicker than a 1 over x squared function. That means this area must be smaller, so this must also be convergent. If we take a look at the cube root function, okay, this is now integrating across 0, across that asymptote. So now I need to look at the graph on the left, and we're talking about the area bounded by the vertical asymptote here, and then we're going to have a symmetrical part down here that's bounded by the asymptote, but since it's symmetrical, we have finite area in this area here, and so we would have finite area down there. So this is also finite or convergent, so we can eliminate that. If we take a look at the same situation here with 1 over x squared, it's going from -1 to 1, so we're going to have this area in here. Well, this area is infinite on the right-hand side, this green area. The area on this side is symmetrical, so it's also infinite. That means that the total sum area on both sides is infinite, so this is divergent. So the answer would be D.